Assalamualaikum and good day. My name is Muhammad Kumi Delfin bin Asatu Delfin. In this slide, I want to share my presentation for my final year project proposal. The title for my final year project is Finite Element Analysis of Ballistic Impact Ceramic, that focusing on impact energy and baking plate. So, for my project summary, ceramics is one of the hard material it widely being used in the armory system to protect body from getting hit by the projectile. However, in terms of toughness, ceramic is one of the material that very brittle and easy to crack. So, the aim of this study is to develop a 3D finite element model analysis on the ceramics due to ballistic impact, that focusing on impact energy and baking plate. This analysis will be fully conducted with 3D modeling by using Abacus Explicit as the main software. In this analysis, Johnson Holmquist 2, which is JH2, and Johnson Cook, which is JC, will be used as the damage model. The expected outcome of this study can shows the residual velocity, deformation, and energy absorbed by two different types of backplates against three different impact energy. This project could become reference to those that need comparison between different backplates and impact energy. Ceramics is one of the important material in the armor production. This is because ceramics have low density, high compressive strength, and high hardness that can be very suitable for armor. From literature review, ceramics usually become the front plate for the model analysis. It works to absorb the initial kinetic energy and reduce the projectile speed once it's touched the model. This figure shows a few ceramics material that usually used for the analysis. Even though ceramics is good for armor, but the material is very brittle. Due to that, the model can be upgraded by applying backplates behind the ceramics. It is to increase the model fracture toughness and the flexibility strength of the model. The requirement of the backplate is it must be in ductile form. The backplate's function is to absorb the remaining energy that transfer by the front plate, and it needs to be not fail on stopping the projectile before the backplates penetrate. The below figure shows type of backplates that mostly being used for any analysis. As for the literature review, there are 15 articles are being used for the literature review. From the figure, it can shows that all of the articles are focusing on ceramics impact, and most of it are applying various type of plates as their support for the model. For the methodology, there are many software that can be used for ballistic simulation, and some of it is LSDNA, Abacus CAE, Abacus Explicit, and ANSYS Explicit. Some of the author are using experiment only to do the simulation to observe the behavior when the projectile impact the model. To get a better comparison and better result, the best method is by using hybrid method, which mean the result gains by experimental and numerical simulation. For the ceramics, it only have one type of damage model, which is Johnson Holmquist, either JH or JH2. Both are the same. Most of the study are also using Johnson Cook as the damage model for the simulation It's for the metal projectile and for the metal backplates. For the problem statement, from the previous study, it not compare the performance for different types of backplates. Next, most of the study are focusing on single impact energy against one type of backplates only. Because of that, less data result that can be difference for different types of backplates against only a few impact energy. So, the objective of this study is to develop 3D modeling of metal and aluminum as the backplates for the ceramics model. Next is to predict the structure failure for both of the model. The last one is to analyze the result obtained in terms of residual velocity, deformation, and energy absorbed from 3 impact energy against 2 types of backplates. For scope and limitation, this project are focusing on few ballistic impact against ceramic model with applying different types of backplates. These simulation are using 3D modeling and using Abacus Explicit as the software to run the simulation. All the data that needs to comparison is obtained from the selected literature review. 6 damage models are being used for the simulation analysis. The methodology for this project is using 3D model and Abacus Explicit as the software for the numerical simulation analysis. It is to develop alumina with Armox 500T steel model and alumina with aluminum model. There will be 6 simulations that will be run by 3 impact energy against 2 types of backplates. The result will show the comparison of the backplates in terms of residual velocity, deformation, and energy absorbed respecting to time will be plotted. Figure beside shows the workflow for the methodology from the modeling until the analysis section. The below figure shows the test matrix for this study, which consists 6 simulations. For this study, the expected result, there will be 6 different 3D model will be developed by using Abacus Explicit. The properties for every material will be shown to choose the best model, either ceramic steel or ceramics aluminum. Using different impact energy can affect the failure behavior of the damage model. The result that obtained from the analysis will be plotted respecting to time. So, here is the Gantt chart through this semester for the FYP proposal. Along the way, most of it are following what has been planned. So, that's all for my FYP proposal presentation. Thank you and have a good day.